Hello students, today we will discuss seeing this UV visible spectroscopy. Lamberts Law, which is a very important law, and it tells us about the quantitative relationship between light absorbed and light transmitted by the absorbing medium. So absorbing medium may be the solution, and this solution has characteristic molecules inside them, and these molecules they may enter or they may absorb some kind of incident energy, and ultimately light is transmitted, which is the least in comparison with incident light. Okay, so here we may inform these two laws separately. As name indicates, Beer's law is a separate law, Lamberts law is also separate law, and when we combine these two laws, we will get the combined equation for this Beer-Lamberts law. So let us have a look on Lamberts law now. So as usual, this law tells us about the quantitative relationship between light which is irradiated and the path length in which it is measured. Okay, so this law states that when a beam of monochromatic light is passed through absorbing medium, then its intensity decreases exponentially as path length of cell goes on increasing. So it is mathematically written like this: I is equal to I0. In the exponential manner, it decreases with path length. So minus sign indicates that it is decreasing. Okay, so now second law is Beer's law. So this law talks about concentration of absorbing species. So when beam of monochromatic light is passed through absorbing solution, then its intensity decreases exponentially as concentration of absorbing medium goes on increasing, and it is written like this: I is equal to I0. In the exponential manner, it decreases with concentration. So here it is I is equal to I0 into exponential function minus of K2 and C. So here C is nothing but concentration of absorbing solution. So when you look to these two laws, it is seen that there is an exponential decrease in the light which is made incident in the exponential manner. That's why we have put here negative sign. So negative sign indicates that decrease. Okay, so intensity decreases exponentially with respect to path length and with respect to concentration. So here when we combine these two equations, that is equation number 1 for Lamberts law and equation number 2 for Beer's law, then we will get, now when we combine these two laws, that is Lamberts law and Beer's law, we will get quantitative relationship and ultimately combined law, that is Beer-Lambert law. So now when you look to this laws, it is seen that left hand side is found to be similar, and only change is seen in these two terms, that is path length small l and concentration small c, and rest of the terms are found to be constant. For example, K1 for Lamberts and K2 for Beer's law is constant, right? So now we will write combined equation of these two equations, that is I is equal to I0 exponentially it decreases with respect to concentration terms, and these two constants I have written, that is C and L. Now since K1 and K2 are constant, we can write here common K for these two terms, and it is now changing I0 exponentially minus of K, C and L. So when you divide this term by means of I0, you will get E minus of KCl. Okay. So now when you take logarithm of I0 to base E minus of KCl. So in this connection, now we will take a numerator to denominator and take corresponding change. So term become I0 upon I, in minus sign goes out, and here it is KCl, isn't it? So this term, logarithm of intensity of light which is irradiated to the transmitted light, that is ratio of light incident to transmitted, is nothing but absorption, and this ratio of transmitted light to incident light is called as transmission, isn't it? So these two terms are now reversed, and when you change this logarithm of base E to base 10, equation becomes log to base 10 I0 upon I is equal to K upon 2.303, which is a new constant now, and we can place this K upon 2.3 as a new constant, that is small k. So log of 10 I0 upon I is written like this, psi C and L. So this new constant K upon 2.303 is called as epsilon, and log of base 10 I0 upon I is called as absorption, and it is written like capital A. So A is equal to psi C and L. So this is the combined equation of Beer-Lamberts law, and when you look to this equation, it is clearly seen that absorbance is directly proportional to concentration and path length, and here epsilon tells us about molar absorption when concentration of solution is 1 molar and path length of cell or cuvette used for the measurement is 1 centimeter. So absorbance is equal to epsilon, and this is the main equation, that is absorption, which is a now molar absorptivity, is nothing but molar extinction coefficient, and where it is measured at maximum wavelength we call it as a psi max. So psi max indicates that what is the concentration level or what is the intensity of absorption, and that is located with this solution, which is a very common term in the UV visible spectroscopy, that is psi max and lambda max. So when lambda max is selected and when we measure the absorptivity, then it gives information regarding the epsilon, that is molar extinction coefficient. Only case is that we need here dilute solutions. So Beer-Lambert law is operated or it is well executed for those solutions which are dilute in nature. For concentrated solutions, this law is deviated from the linearity, isn't it? So provided that it does not shows association, dissociation and also reaction with solvent. So species must be inert and solvent must be non-absorbing at all. So most of the time water, carbon tetrachloride, benzene, acetone, these solvents are used for the measurement purpose for various absorbing species. Okay, so here Beer-Lambert law is quantitatively selected for those compounds whose unknown concentration is to be determined. So very simply, application of this Beer-Lambert law in our chemistry laboratory is for measurement of color intensity, that is colorimetric analysis. So in this colorimetric analysis we may infer unknown concentration from the absorbing species by preparing series of dilutions, and from that dilution we are measuring its wavelength and we are selecting lambda max, that is maximum wavelength where there is a maximum absorbance, and we may locate unknown concentration in this fashion. Okay, so very crucially, this law is having application in the field of various color intensity and color compounds and their detection. Okay, so this is the all about Beer-Lamberts law. Thank you.